In this video, we're going to look at example 4 in section 12.4 linear functions. So in this example, we're given 3 different contour maps or contour plots, and we're asked to determine if each could represent a linear function. And for those that could, we want to find the formula for it if possible. All right, so we're going to do the first one together, and then I'll let you work out the last 2 and check your work. All right, so let's look at this first contour map. And the method that we're going to use can be used for checking the rest of the 2 graphs as well. All right, so we're first going to consider if we have a constant slope in both the x and y direction. So notice this is just my xy axis. Here, this 10, 8, 6, 4, 2, 0. Recall those are the values of z for this line. So it's as if maybe we can visualize what's happening here, where we've basically smushed our whole entire plane down to this xy point, though this line here should be 10 units up. This line should be 8 units up off the page. This line here, 6 units up off the page. So that's kind of what's going on. So that means if we want to look at what's happening to this graph in the x or y direction, we're just going to fix a line going through or with a fixed y or a fixed x. So I'll draw that out and then talk about it a little bit more. So what that means is if we fix, say, y to be here and look at this line that I've drawn, this can help us determine the slopes in x direction. Because notice a points on our graph here. What would they look like? Well, they would look like here. Let's see, I'll count this over 1, 2, 3, 4. Here, x is 4, y is fixed at 2, and z is 10. For this point, we have x is, oh, that should be a -4. Good catch if you saw that. -4. So here x is -1, y is 2 again, z is 8. For this point on our curve or on our graph, we would have actually the point 2, again 2 in the y, and then 6 in the z. So notice the y values here, 2, 2, and 2 are not changing, but the points in the z and x are. So here, this curve, this green curve, would allow us to compute that slope in the x direction. And then similarly, we can look at a vertical line to tell us about the slopes in the y direction. So we can look and we can even plot some points if we want to help us. So here, this point would be 2, 0, 4. This point would be 2, -2, 2. Okay, so this is going to help us determine the slopes in y direction, if we can. So before computing slopes, because we don't even know if this contour plot could represent a linear function, let's just think about what it would mean if it could. So we need to have the slopes in these x or y direction be constant. So notice that the changes in the z are 10, 8, 6. So 10 to 8, that's going down 2. 8 to 6 going down 2. So it looks pretty good. And then our changes of the x's are also that same or also constant. So 3, 3. So it's looking like, yeah, we have a constant slope here. And then also we see that in the y direction. So the z's go from 2, 4, 6. The y's go from -2, 0, 2. So it looks like we're changing constantly in both directions. So then, yeah, let's go ahead and write the equation for this linear function. So recall that equation looks like z equals z naught plus m times x minus x naught plus n times y minus y naught. All right, so we need the slopes in the x and y direction, and then we need a point on our graph. So let's go ahead and compute the slopes in the x direction. So we want to compute the change of z compared to the change of x. So we can just pick 2 points to do that. So I could pick these 2 points. So the change in the z coordinate is 8 minus 6. The change in the x coordinate is -1 minus 2. So -1 minus 2. So that gives us a slope of 2 over -3, which is -2/3. So that gives us the slope in the x direction. So now let's do the same thing with the slope in the y direction. So for the slope in the y direction, I'm just going to look at 2 points. I could look at this 2, 2, 6 again, and 2, 0, 4. So we're going to compute the change of z compared to the change of y. So the change of z, so z is 6, and then z is 4, so 6 minus 4. And then the y, we have 2 minus 0. So that gives us 2 over 2, which is a slope of 1. Awesome. So there we have the slope in the x and y direction. So now we just need a point on our map. So we can just find a point. So we've already highlighted some of them. So our point x naught, y naught, z naught. Why don't we just use this guy, 2, 2, 6, because we've used it a bunch already. Might as well let it stick to be our favorite. So now we just need to plug in that point and the slopes that we found into our equation for the line. So we can do that now. So this means that the equation can look like z equals 6 minus 2/3 x minus 2 plus 1 times y minus 2. Awesome. So we could clean that up a little bit by just multiplying the 1 throughout. So if we want to be a little cleaner, we can leave it like that. Awesome. All right, great work going through this problem. So when you're checking the rest of these 2 graphs, you're going to want to check to make sure or see, first of all, if these two contour plots are representing constant change in the x and y direction by looking at lines that are parallel to the y or x axis. All right, thanks for watching. Keep up the hard work and check your results when you're finished.